Good afternoon, everyone. My name is Gretchen Walters. I'm with HYDAC Technology Corporation, and welcome to our distributor training webinar. Today, we'll be hearing about StatFree and StatX. Before we begin, I wanted to thank each of you for taking the time to attend our webinar today. We very much appreciate it. I had a few housekeeping items I wanted to go over. I'm sure many of you have noticed by now that you are muted. We will be having Q&A at the end of the webinar, at which point I will give everyone the ability to unmute themselves, and I'll let you know when this happens. If a question is pressing, you have a little mitten on your dashboard with which you can submit a question through chat. I know folks also asked if this webinar is being recorded, and in fact it is, so it will be available after the presentation. And I wanted to say a little bit about our presenter today. Our presenter is Babuvi Pandya, and he is the Group Product Manager for Hydraulic and Lube Filtration. And with that, we welcome you, Bav. Take it away.
Thank you. Thank you, Gretchen, for introduction. Thank you, everyone. Good afternoon. We'll be talking about the hydraulic and lube filters and filtration, and also the application in which we are commonly now saying electrostatic discharge and charging and discharging events. So with that, diving into the HYDAC technologies, StatFree and StatX filtration, how to resolve and how to mitigate those issues going into the field. So going into the material characteristics. So first, what we are looking here is the group 1, group 2, and group 3 oils. API has actually developed these different classification of the oils and lubricant oils as well as the hydraulic oils. And in the industry, the trend is now moving forward, utilizing the group 2 and group 3 oils. These oils were initially started in the market around 1990s, and in that time period, HYDAC had started seeing some issues going with our filtering these group 2 and group 3 oils with the electrostatic charging and discharging events. So upon doing different chemical analysis and also understanding what is causing this, so we started doing analysis on these group 2 and group 3 oils, and understood that we have very highly refined and hydrocracked oils that are not similar to group 1 and but these hydrocracked and highly refined oils are now having very good chemical properties. So those properties are actually helping OEMs couple of ways. One is the viscosity index, which is very high or very good viscosity index, helping them to maintain the oil properties throughout the wide range of temperature. But at the same, and also it's having group 2 and group 3 oils also having very less or no content of zinc and ash, making them biodegradable. So having those two main properties, ecological as well as the chemical properties, they were widely being utilized starting around 1990s. But as always, when you have good stuff going on, you always have something that actually contradicts to your agenda, and that's this oil prohibits to utilize at a lower temperature, at much lower temperature, because these oils are typically now are exhibiting very low conductivity. Having those low conductivity, they interact with the glass fiber that is being utilized as a filter material. So what we are going to talk here is 4 different parameters. These parameters are very important to understand, and we want to keep them in mind throughout this presentation, because we'll be utilizing these characteristics and also attributes throughout the presentation. So conductivity is the key parameter. When you have the low conductivity of the oil, that has a higher tendency to charge. Conductivity is normally measured in picosiemen per meter. So when we have a picosiemen per meter conductivity measured and at a different temperatures, you are going to have different results. So conductivity and temperature go side by side. As you see in the graph on the left side, group 2 and group 3 oils are exhibiting very low conductivity at a temperature range, room temperature, as well as the normal operating temperature, which is 50 degrees C, as opposed to group 1 oil, which is at room temperature around 500 picosiemens per meter, and at normal temperature, or the working temperature, about 2000 picosiemens per meter. So that is very high compared to group 2 and group 3 oils. So conductivity, temperature, filter material, the material which is used to construct the filter element, and when this material interacts with the oil. And finally, the hydraulic load. So hydraulic load is defined as the surface area of the element, or surface area of the filter element, and how much amount of fluid is going through this element. So it's basically considered as a flux of the hydraulic velocity, or the flux of the hydraulic flow. So we are going to keep these all parameters in mind throughout the presentation, so we can relate them as we go along. So in order to understand the electrostatic charging and discharging, we are first going to talk about the electrostatic charging in the solid, and then in the liquid and the solid material. So when you have two dissimilar material having two dissimilar electron work function, when these two material getting together, when they come close to each other, it doesn't need to be in contact with each other. It just needs to be as close as 0.01 micron or closer to that. It tends to change the electrons, and one having that tendency of changing or exchanging the electrons, one becomes positively charged and the other becomes negatively charged. Having two dissimilar material and having this charge separation, they are going to form a phenomena called double layer. A double layer can happen in any object that is either solid, gaseous, or any sort of liquid. So having that double layer formed, now when these two double layer material try to separate, depending on the separation force or the separation speed, it tends to get charged, and that charging, it could be very high when this separation happens very quickly. So as you can see here, the faster the separation, higher the charging, because it has a less time to discharge or less time to get back to the equilibrium state. So having the faster separation and very high charging, it acts as a capacitor. So it tends to it wants to go back to equilibrium state, but it's not going to happen unless and until you have the medium that is in between, that is called dielectric medium. And if that medium's constant, dielectric constant, is weaker than the charge that is collected on each of these materials. So if the dielectric medium between element 1 and 2 is weaker, then the charge is going to jump from one to another and tries to go back to the equilibrium state. And that discharge is called electrostatic discharge. Now, this charging behavior of these two materials of solid can be understood similar into the liquid system as well. So consider the wall here that is shown a glass fiber wall, or the wall of the element, and the fluid is our lubrication oil or the hydraulic oil. When the hydraulic oil is going through the filter element, it's going to create, it's going to exchange the ions, and the oil typically becomes negatively charged, and the wall, or the glass fiber wall, it becomes positively charged, and it becomes it forms the double layer similar to the solid material. And on like very outside of the far away from the charge glass fiber material, it's going to create a diffuse layer, which means that the charge is going to be carried away by oil downstream of the filter element. So here, in order to generate the charge, again, you need to have the phenomena called the electron work functions, as well as material with the two different electron work functions, and those two work function needs to be closely related with the turboelectric series that is shown on the top end corner of this slide. So how does that work? Can any element have an electron work function different and still be charged? Not necessarily. So that's what we're going to be talking about. So in order for a material to get charged, if you see on the top right corner, the glass is basically the glass fiber, the third item from top down. Glass is the glass fiber material, and polyethylene or polyurethane is basically the finely hydrocracked oil that are far apart in this turboelectric series. So going into the next slide, which is making it much clearer. So going into this turboelectric series, glass is the typically gets positively charged, and anything urethane or polyethylene becomes negatively charged. And because of this having a huge difference in the charge electron work function, oil tends to take the charge away from it and goes to the downstream of the filter. And because of this charge separation or charge generation, electrostatic discharge occurs anywhere in the downstream of the filter. In order to avoid that, we need to select the material of the filter element that is close to the oil, and it behaves or works very close to the oil electron work function. So HYDAC understood this phenomena back in 2000 timeframe, and in 2000 timeframe, and developed stat-free technology. So what is stat-free technology? So stat-free, at the time when we come across this phenomena, HYDAC created the fiber matrix, so that is working very close to the close to the electron work function of the oil, and hence very low charging of the filter, element as well as the fluid, and we essentially come to a point where we did not have any electrostatic discharge issues because of the low charging. Cannot jump from one to another because of the dielectric constant was strong enough. So when HYDAC developed the stat-free elements, we started successfully employing them into the power plants where there is a very high hydraulic load going into the system, very low conductivity. Plastic injection molding machines, we successfully employed that where the conductivity also was lower and very high return flow, causing the higher hydraulic loads. Similarly, in the hydraulic press applications and mobile hydraulic applications. So having all of these successful applications, stat-free employed into these successful applications, we got good experience understanding the phenomena. But as we got more and more into this technology and more oils getting refined, a concept called gas to liquid came into place. And what is that gas to liquid phase? Basically, it's a synthetic type of oils. They are also very highly refined and also exhibit very low conductivity as low as 2 to 3 picosiemens per meter at normal room temperature. And having such a low conductivity, HYDAC got more experience working in these type of applications and developed another technology, StatX media. So StatX technology helped us refine the applications and successfully employed this application, static technology, into the gas turbine app, which is specifically in the GE applications, where the GE 7FA and a newer frame, where the hydraulic load was almost double than their previous generations. And the same thing in the forklift applications, where most of the forklifts were utilized in the cold storage, having very low, as you see, the conductivity and the temperature are very correlated. So the conductivity goes down when the temperature goes down, and then lower temperature operation of the forklifts caused a lot of issues with the electrostatic discharging, especially with the plastic tanks. And also the drilling rigs when mainly operated into the colder climate. So having those application and challenges in front of us, HYDAC developed the media that was sophisticatedly working in these applications and helped us to worked at much lower temperature and much lower conductivity at much higher hydraulic load. So how does this stat-free and StatX are separated, and how do they work? So when we go into the applications, first we look at the symptoms. What are the symptoms going into this application? What are the symptoms? So you might be aware of these symptoms. You're still in front of your computer, not anywhere that you don't want to be, but these are the symptoms that you normally see across the world right now. But we'll be talking about the hydraulic symptoms or symptoms into the hydraulic and loop systems. Since you are a hydraulic doctor, we'll be talking about the symptoms in the filter element, oil, and filter systems. So in the filter element, you will have your question to your application folks would be, do you guys see any burn marks into the filter media? They probably say no, and they may not be even aware of that. So your next question could be, do you see any burn marks in the support structure, like a support tube of the element? They probably say no, because they haven't looked into those elements. But your key question now that will definitely raise some eyebrows, have you seen any rise in differential pressure across the element over a prolonged period of time? And that answer could be no as well. So if that answer is no, that means you're having, the application is having the electrostatic discharge causing larger holes into the media and making it more porous and allowing the contaminant go through those elements, through those pores, and not causing the higher pressure difference. So you might be seeing something like this. So when you go into the oil level, the question could be, do you see higher accelerated oil aging? Meaning, let's say if you have a total acid number, if the total acid number is increasing at a much higher pace than you would normally see. So because of the antioxidants are forming very high 10 number. Then varnish formation. So if you have very high varnish generation also within a very short period of time, then that could also be another indication. So, and finally, at the filter or the system level. So the question could be, do you hear the ticking noise? Those ticking noise could be at a much lower, could be increasing that ticking frequency at a lower temperature. So do you hear that ticking noise? Secondly, do you see any damage to the electronic components? Because when you have the electrostatic charge generated, and especially in the mobile application, when you have the plastic tanks, those plastic tanks tends to form the electromagnetic field around it because of the material of it. And because of that very high electromagnetic field, it tends to ruin the electronic components around it. So that would be the question, like, do you see in the mobile application, do you see the electronic component failures? Do you see in the heat exchanger component failures, like a micropitting and such that, or discoloration of the components? And in normal application, in any other mechanical applications, the question would be, do you see bearing or the gear mesh failure? So these are the typical questions that can actually help the end user to understand that do they have issues or do they not have any issues. And these are the picture on the right side is also elaborating here the electrostatic discharge marks on the filter, between the filter element and the filter housing, causing the discoloration overall from 1/3 of the housing from top down. So here in this slide, what we are showing is the different indications. So the first one is the burn mark that we talked about. So when you have the filter element generating a lot of charge and discharging within the filter element, that is going to cause the burn marks into it and causing the lot of holes and not increase the delta P throughout the service life. Secondly, the oil degradation into the system. Third one would be discharges outside of the system, somewhere in the downstream of the filter housing or filter element. The fourth one here, you can see the breather is actually getting burned because of the very high charge generated into downstream of the filter, which is in the tank. And tank is one of the key component where normally the charge gets generated, and because of the oil air mist in the top of the tank, it tends to discharge within the tank, and having a breather on the top of it catches the fire. And the last one here is the interference of the electromagnetic field generated by the electrostatic charge into the tank, causing the failures of the electronic components. So these are the typical symptoms or the typical indications that you can ask your customer to see if they have these issues. Here are some more pictures, some more elaboration of that. Again, if you have more reliability issues in the valves, valve getting stuck open, stuck closed because of the varnish, and varnish catches the contaminant and causes the stuck open or stuck closed valves. Then more component wear, reduction in the efficiency of the filter element because of the very high localized temperature causing the burn marks into the element. Plugging of the filter because of the varnish and the contaminants. Then performance issues in the heat exchangers because of the micropitting, and also the discoloration of the heat exchanger. Journal bearing failures because, again, same thing, micropitting events, and also the increased maintenance costs. So all of that are indication of the electrostatic charging. Now, we also need to be, there is a fine line between the varnish generation causing due to the electrostatic discharges or the temperature, having constant higher temperature. The constant higher temperature could be the cooling related issues, but the electrostatic discharge and the varnish are also related to each other. And when you have electrostatic discharge, the temperature is anywhere between 2,000 to 3,000 Kelvin. That localized temperature is going to burn the fluid and increase your 10 number, 10, as well as the varnish, generates the varnish. So when HighTech started understanding these different phenomena and different oil, HighTech started putting together categories and like which oil works with which application, and which application you can utilize stat-free or StatX or the standard HighTech standard OptiMicron technology. So HighTech was the first one actually quantifying the conductivity which is related or which is responsible for the electrostatic charging and discharging. So anywhere above 500 picosiemens per meter, we are okay to utilize the OptiMicron. When you have the conductivity between 500 to 50, we are between 500 to 100, OptiMicron power or stat-free are the good technology to utilize. And if you have the conductivity lower than 100, StatX is the element technology we normally go with. So having that, we have comprehensive tool which is accessible to the HighTech regional sales managers. They can also help you to dictate which oil you're using and which technology can be utilized, whether it's a StatX, stat-free, or the standard HighTech standard OptiMicron. So the image of the tool is on the right-hand corner of this slide. So in putting both technology in perspective, stat-free utilizes the media that is forming very low to no electrical potential charge, and also having the same glass fiber structure that we used to have with the standard OptiMicron, and provides you the same level of filtration. StatX filter, on the other hand, is very sophisticated design, modified glass fiber media, helps you reduce the charge generation or almost no charge generation at a lower conductivity, as low as 2 to 3 picosiemens per meter, and provides you the no charging of the oil in the hydraulic or the lube application system. So how do we differentiate between ourselves with to the competitors? So in this, there are 3 different cases here. First is the non-conductive element. So most when this issue started happening, most OEM of the filtration started with the non-conductive element. When you have the non-conductive element, the charge generation happens between the metal or the glass fiber and charge generation into the oil. Upon separation of that charge, discharge occurs and you have the problem. Now, in the conductive element, which is what normally currently is being utilized at most of our HYDAC's competitor, those conductive elements are typically either made with the carbon fibers or the metal fibers engraved into the glass fibers. There is a pros and cons. The pros is, yes, you're eliminating charge at the filter, but the charge is still being generated when the oil is passing through the filter element. And when the charge is passing through the when the oil is passing through the filter element, that generated charge is going through filter element and downstream of the filter element. So the charge that is generated because in the filter element is going to get grounded, and you will not have any discharge at the filter element level. But you're not solving the problem. This problem is still existing, which is the charge in the oil. And that charge on the oil can only be mitigated if you have the filter element that is compatible with that oil, so that it doesn't exchange ion and doesn't get charged. And that's what HYDAC's stat-free and StatX are doing. So stat-free and StatX elements are making oil are compatible to the oils and not exchanging any ions and getting less to no charge in the oil as well as in the filter element. And hence you have the very safe operating conditions. So here is an example of the charging behavior of 3 different media. So remember, we talked about the flow or the hydraulic flux or the hydraulic load. When you have very high hydraulic load, and the rest is the same operating conditions, same fluid, same temperature, same conductivity. But when you have very high hydraulic flow going through the same surface area of the element, the standard HYDAC standard optimicron element tends to get charged more. Stat-free element tends to charge less, and StatX almost charges none. And the other key thing that you want to observe here is the charging behavior of the oil. The charge in the oil is always negative. As you can see in the standard element, the charge is almost between 1500 to 2000 volt. In stat-free, it limits up to 1000 volt, and in StatX almost null. So that is the key difference in this application, or when we did the testing to show the different behavior of the element and how the tendency of the charging in the oil when these elements or the technology are employed. So putting all of that into one equation, when you have the hydraulic or the lube oil with very low conductivity, and when you're filtering that oil through the glass fiber media, you are going to have the electrostatic charging and discharging when you have the very low dielectric constant. So this is always going to hold true as long as you are using these 2 conditions. Now, when you have the hydraulic and lube oil with low conductivity, and you're utilizing the filtration or you're utilizing the modified glass fiber that doesn't act as a glass, but still gives you the good property of the glass fiber filtration, you're eliminating the root cause of the ion exchange. And because of that compatibility between the low conductivity oil and the StatX and stat-free, that charge generation doesn't happen, hence no electrostatic charging and electrostatic discharging. So typically how HYDAC processes this type of inquiry. So when we have customers mentioning about the charge electrostatic discharging, first thing we talk about is the conductivity of the oil. We currently have a few conductivity meters out in the field with filter application engineers and the different regions, and of course in the lab in Bethlehem. So you can always either have the filter application engineer in your region to help you discuss about the conductivity of the oil, or you can send the oil to HYDAC about 200 milliliter to test the conductivity of the oil. Once we know the conductivity of the oil, then we discuss about, let's say, how much charge is being generated. So we can either do the charge measurement at the site, or we can always take the oil in our lab and try to see how much charge is being generated with the same application. Usually, it's better to do that testing on site so that we are doing the measurement in real life conditions and real parameters. once we know the charge generation and once we employ the right technology, we do the charge measurement again, making sure that the technology and customer is happy and technology works how it's intended, and customer problem gets resolved by doing such. So, and in the summary, we have the StatX and stat-free element. Stat-free element is normally utilized when the conductivity is up to between 100 to 500 picosiemen per meter. If the conductivity is lower than that, we normally use the StatX. Even if the conductivity at the normal temperature is between 100 to 500, but at a colder temperature where the most of the time application is going to be running at, we would use the StatX element. So always keep in mind the conductivity is the key parameter that we normally look at the normal operating temperature to dictate the technology that we want to use. So with that said, we are going to talk about some of the HighTech success story working with some of the distribution. In this case, we worked with Airline Hydraulics. So I would thank Airline Hydraulics and their constant engagement with GE. So working with them, so GE came to Airline and selected the site where they had the most electrostatic discharge related issues. That was 7FA frame. When they designed the 7FA frame from 7EA, they pretty much used the same lubrication system as the 7EA, but they increased the flow rate by 2. So they had 450 GPM. Now we are seeing 900 GPM, and they kept the same filter in the application. So when they did that, the hydraulic load now has increased almost 2 times. Because of that hydraulic load increase, and of course the different types of oil being utilized, the electrostatic discharge, charging and discharging events started staying in the field. When they started having these issues, and especially with the very fine or the refined oils, some of the engineers at GE were actually telling the end users to run the duplex filter, keeping the transfer valve handle in the middle position. By doing that, now you're utilizing all same elements, but half the flow rate. But you're not utilizing your duplex housing as a duplex, real in duplex configuration. So when HYDAC came to know about this problem, we employed the StatX in that application and showed them the difference between the charge generation before and after. GE did multiple measurements at the time of the implement of these elements and 6 months later, and proved out that the element works throughout the intended service life and does not create charge in any condition. So whether it's the flushing condition or whether it's a normal operating condition. So hence HYDAC got specified along with Airline as a supplier for this type of turbines. And because of that, now we are on the multiple, any 7FA as well as the newer frame 8HA and other frames. So HYDAC is now specified along with Airline as a supplier, and GE has recognized and allowed HYDAC's logo on the outer wrap of the filter element. So now we can see on the right side, GE as well as the HYDAC collectively are now making these elements and utilizing them at the higher any newer turbines that are being utilized. The latest, now this success story is from 2015. Since then, many things have changed. As I discussed, gas to liquid fluids gas to liquid lubricants are more populating in the market, and because of that, we are seeing more and more issues that competitors are actually facing and not able to resolve that. And this slide actually shows such event where the OEM basically came to HYDAC saying that we are actually seeing this issue, and one of the HYDAC's competitor, Hilliard, which is also on the specification, are not able to resolve that, and they are actually confronting their technology not being effective anything below 50 picosiemen per meter, and in this particular case, the oil utilized is Shell Turbo S4GX, which is gas to liquid fluid, and having very low conductivity, 2.2 picosiemens per meter. And HYDAC has experience with that and has resolved issues with that. And now we are being asked to help GE to resolve that issue as well. So I would like to thank again airlines for their continuous engagement, promoting this statics technology as well as the stat-free technology and helping to educate the OEMs as well. So thank you for your support. With that, I have one quick tool that I would like to introduce to you as well. We have the power gen value hypothesis, where we have put together different conditions, different attributes that power gen industry normally uses. And when they have the electrostatic charging and discharging related events, their oil is going to degrade. And because of that degradation of the oil, they have to use some sort of a varnish removal system. And because of that high price of the varnish removal and maintenance of that, versus utilizing the HYDAC stat-free technology or statics technology, how that's going to help and reduce their overall operating cost is what we have put together here. And this is very dynamic worksheet. Again, your regional HYDAC territory or the area sales manager have access to that, along with the filter application engineer. So you can always reach out to them, or you can reach out to me as well, and we can work together to get this value hypothesis put together for your MRO customers or the end user customers. With that, I'd like to thank you everyone for your attention as well as your support throughout the technology development.
Wow, Bob, that was a lot of great information.